Happy Monday, guys. We got a test tomorrow, and this is one of the 3 problems I gave to you to get ready in preparing for tomorrow's test, along with the review that I've given to you last week. So I just wanted to go over these problems with you, and instead of doing them in front of the classroom, I thought I'd just solve them tonight, post them online, and then you could watch them freely at will, wherever you felt like watching them. So first, using the following matrices for exercises 18 to 21, evaluate if possible. So we just want to figure out what is 1/2 of h plus j. So the first thing you got to make sure is, can you add h plus j? And if you can add those, we'll just add those first, and then we'll distribute this 1/2 into each of the values in the matrix. So how do you determine if you can add 2 matrices? Well, the matrices have to have the same dimension. So let's see if h and j have the same dimensions. Here's h and here's j. H looks like it's a 1, 2, 3 by 2. So 3 by 2, and this one is a 1, 2, 3 by 1. So they do not have the same dimensions, therefore you cannot add these two. Now that only works with adding and subtracting. They have to be the same dimensions for adding and subtracting. It's a little different once you start talking about multiplication, but that's not in this problem, so we won't worry about that. Let's move over to the next one right here. Let's see if we can figure out what is 2k minus g. Again, first you want to make sure k and g are the same dimensions. So we'll check out k. Here's k. It's a 1, 2, 3 by 2. G is a 1, 2, 3 by 2. So they do have the same dimensions. Great. So we can figure out, or we can subtract these two. The key thing when I do this is I like to figure out what is 2k first. We're going to figure out what 2k is, get that done, and then we'll subtract the g. So 2k, what I'm going to do is for each of the k values right here, I'm going to multiply each of these values by 2. Okay, that's really what's happening with this 2. You're distributing the 2 into each of those values. So 2k would look something like this. Once you distribute those values in, 2 times 2 is 4. 2 times 3 is 6. 2 times 3 is 6 right here. 2 times -1 is -2 right there. 2 times 5 is 10. And 2 times 0 is 0. So right now I have my 2k. Now we're going to subtract the g. So what I'm going to do is, let's just kind of write the g down here. Where's my g? Use my g function. I'm just going to transpose that. That's a math term, guys. 5, 2, 5, 2, -2, 0, 0, 1. Okay. Now the key to subtracting is to subtract each address, or match up the parts. Like this 4 goes with that, so the top left goes with the top left. So we're going to do 4 minus 5. The reason I'm doing minus because we're subtracting there. 4 minus 5 is -1. Then we'll do 6 minus 2, which is 4. Then we'll do 6 minus -2. That's 8. Think about that one. -2 minus 0, that's -2. 10 minus 0 is 10, and 0 minus 1 is -1. So our solution to this right here is right there. I'll just circle it in orange. Okay, so this is how you add and subtract matrices. First, you got to double check that you can do it. This one was not possible. Once you can tell that they have the same dimensions and you can add and subtract, take care of the coefficients that are in front of the matrix. Distribute those into the matrix. Then, once you distribute that in, may you subtract or add those matrices. So, anyway, that's how you do problem number 1. Hopefully this was helpful.